Okay, so we are going to start topic 2 today. And topic 2, there's a little bit of overlap as far as, sorry, thank you, topic 3. There's a little bit of overlap with topic 2. That's why topic 2 was in my brain, was because I was trying to say that. There's a little bit of overlap with topic 2 in that we know what slope is, we know what y-intercepts are, we know what constant of proportionality means. And so we're kind of going to build on that a little bit in topic 3. And then of course, if it was identical, we wouldn't need a topic 3. So there is a few new things. And one of those new things, and I'm not sure if you guys did this because like I said, you guys are the group that skipped over 7th grade. So we're going to talk about what a relation is, which is just a set of ordered pairs. And then we're going to talk about what a function is. And there's kind of a mathy way to know it. And then there's a silly memory trick I give you. And whichever one makes it stick in your brain the best, that's the one that I want you to remember. So, all right. So if you look at these boxes, let's say you're going to the post office, right? And you've got a box that weighs 8 pounds, 9 pounds, 10 pounds, 14, 12 pounds. Does it make sense that they would all be different amounts to ship it, right? That makes sense in a kind of just in a worldly example. And so what they've done here is they've taken those boxes and they have put them as ordered pairs. So this means that an 8-pound box would cost $8.56, a 9-pound box, a 10-pound box, and so on. And one of the things it asks is, should Jonah expect that the cost to ship a 15-pound box will be a unique cost? Well, does the fact that every one of these being unique, does it make sense that a 15-pound box would even be another unique number? So that makes sense to us. The other thing I want to show you is this input and output. Would you ever go to the post office and say, I would like to pay $5.42. Can you tell me how much my package should weigh? You would never do that, right? You would walk in and say, here's my box. They weigh it. If it weighs 5 pounds, then they tell you how much you have to pay, right? So the input is your X, okay? The input is what's the information that you input into the equation, and then the output is the result of that. So like I said, in this case, you would go to the post office and they would weigh your box and they would put that weight in the computer, and the computer would spit out how much you owe the post office. And so what I want you to note on your workbook is that the input is always your X and the output is always your Y. Okay, the input is always your X and the output is always your Y. And the reason for that is if you think about, and this is just kind of, I can even do it up here. You don't even have to write this down. The reason for that is if you have Y equals MX plus B, right? We've been working with this. And let's say I make up an equation and say Y equals 2X plus 3. Okay. My input would be my X because I would input a number in for X. Let's say I picked 3 to be my input. If I input that, and then run it through the PEMDAS machine, I would get 3 times 2 is 6 plus 3. So I would get Y equals 9. So when you input the X, in this case, the X of 3, when you run it through the PEMDAS machine, it pops out a Y of 9. So this could be written as an ordered pair, 3, 9. And what that means is that 3, 9 is a solution to our equation, because when we input 3, it spit out 9. And it's kind of like a Hershey Kiss factory. At the beginning, you've got all the ingredients, right? You've got the sugar and the cream and the cocoa and all that goes into making a Hershey Kiss. You input it in, it runs through the machine, and then on the other side is a little conveyor belt popping out little Hershey Kisses. So your X is always your input. So if you're trying to figure out, if you're given data and you're trying to figure out which is the X and which is the Y, think about which of the two would be the one that you would input the information, and then which one would change based on that input. Okay. And usually, and I haven't run into any problems yet, but usually when you're in a table, the X is always on the left, the Y is always on the right. When you're an up and down table, the X is always on top and the Y is on bottom. And when you write it as an ordered pair, the X is always written first and the Y is always written second. And then we're going to introduce a new one today, a new way to look at ordered pairs, and it's called mapping. So we'll talk about that in a minute. Okay, so that's just kind of an intro into what we're doing. So let's look at, here we go. Nope, not that. There we go. All right. So this is our boxes and their corresponding weights. Okay. So 8 pounds, 9 pounds, so on and so on and so on. This is one way of delivering the information. This is a set of ordered pairs, and the vocabulary for that is called a relation. And just like I wrote on that other page, some ways that you can be given this information or given a set of ordered pairs. One is it can look like this. And it's just a bunch of ordered pairs that look like this. Okay, that's one way that you can be given a relation. And those would be X's and Y's. Those would be ordered pairs. The other way that you could be given this information is an XY table or an XY chart. Okay. And the other way is the new one we're going to talk about today, and it's called mapping. And the reason I want to use the term mapping is because when you take algebra and you take other high school classes, it's called mapping. But in this book, and I want to make sure you know this because you're going to have to know it to answer some questions today, it's called an arrow diagram. I've never ever heard it called that anywhere else but this curriculum. But that's what it's called in this curriculum. So in this curriculum, when they ask you to do an arrow diagram, most of the time I'll probably refer to it as mapping just to keep you used to that, because that's what you will hear at the high school. But again, you got to know what they're asking when this curriculum asks you to do an arrow diagram. Okay. All right. So if you look at, this is the relation. Remember I said the relation is just a set of ordered pairs. This is one way to state the relation. It's just a bunch of ordered pairs. This is another way to express that same relation. And this is what mapping looks like. In mapping, this is always your X. This is always your Y. Your X is always on the left, just like in a table. In the X bubble, those are all the X's represented in your information. And if you look at your stack of boxes over here, right, these right here are all the X's. Notice 8, 9, 10, 12, 14, 8, 9, 10, 12, 14. And then in the Y bubble, right here, I'm not going to say them all because they're all decimals and that would take me forever, but these are all your Y's. And so they go in your Y bubble. And then how you know which one goes with which is where the arrows come in, which is, I'm assuming, is why they call it an arrow diagram. But when you draw a line between 8 and 856, you're saying that 8 and 856 are an ordered pair. They're an X and a Y. They're an ordered pair. When you draw a line to the 9, to the 10, to the 12, and to the 14, okay? The other term that I want to introduce you today is a function. A function is a very special relation where each X goes out with exactly one Y. Okay, so if you look at this example, this would be considered a function. So the question, yes or no, is this a function? Yes, this would be a function. Why? Because the 8 only goes out with this Y. The 9 only goes out with this Y. The 10, the 12, and the 14 each only go out to one Y. Okay, so if you were to answer, is this a function? And I want everybody to write this down because this is what you're going to put on your homework. It's going to say, is this a function? And then it's going to say, explain. If you answer yes, that it is a function, here's what your explanation needs to say. Each X has, sorry about the handwriting, I have to hover today, and this pen is not exactly the best. Has exactly one Y. That is your explanation for yes. Is it a function? If the answer is yes, then this is your explanation. So highlight this, put stars next to this, whatever you have to do to notate in your notes that this is something important that you're going to need to go back and reference. Okay? And we're going to do an example of one that's not a function so you can see how to easily identify a no. And then I'll show you how to answer the no's. Are we good on that? Is it a function? Yes or no? You have to look at your X's. Your Y's can do whatever they want. So you don't care what the Y column's doing. Y's can go out with as many X's as they want. It's just your X's that you care about. And the silly way I say it is you don't want to have any cheating X's. That's usually how they end up your X. Okay? No cheating X's. Y's can do whatever they want. No cheating X's. Okay? What? I can do whatever I want. That's right. I always say it's like husbands and wives. Wives can do whatever they want. But No cheating x's, right? So in this case, each x only goes out with one y, no cheaters, we're good, okay? So let's look at this try it. And we're going to do a lot with this try it. So this is how to construct a map, okay? So what you want to do is you want to look at your ordered pairs, and that's over here, right? This is your relation right here. And you want to look at in each ordered pair, what's your x? Well, in this case, you've got 4, 5, 8, 2, and 9. Okay, those are your x's. And so that's what's going to go in your x bubble. So and they've already got some of them filled in. And you always want to do it smallest to greatest and never write repeats. Okay, don't write repeats. So in this case, what x's do you have? Well, you've got the x of 2, which they've already written. Then your next one in order is 4. And so that's the one we need to fill in here. And then the next one is 5. They've already filled that one in. Then the next one in order is 8. So we need to fill that one in. And then the next one, they've already filled in 9. And if you look at your y's right here, they've already filled those in for you, right? They already fill in your y bubble. So to do a map, you do 2 bubbles. Always, always, this is always your x, this is always your y. Now, the last step is you actually have to tell the reader of this what goes with what, because it's not always straight across like that first one. So if you look at this first point right here, it's the point 424. Those go together. So you come over to your map and you actually attach 4 to 24 with an arrow. Then if you look at your next point, it's 535. So you're going to connect 5 and 35 together. Then you look at your next point and it's 824. Well, 8 goes up here to 24. 2 goes to 20. They've already connected that one. And then 9 goes with 27 because those two are together as an ordered pair. So 9 would go up here to 27. Now, if I ask you, is this a function, yes or no, what would you say? Tell me which x is cheating. 8 goes out with more than one number. 8 goes out with just 24. Nobody's cheating. Is it a function? It is a function, yes. Now, here's where the y comes in. You're going to write this each time. If it's yes, each x has exactly 1 y. That's a yes, and so that's your explanation. Now, some of you said no, and some of you said no because of this cheating 24. The 24 is a y, and y's can do whatever they want. So it does not matter that 24 is going out with 4 in the 8, okay? Y's can do whatever they want. All you care about is your x's. You don't want any cheating x's, okay? Now, the mathy, like the real reason, obviously, when you're reading on iLearn in the spring, you're not going to see an explanation that says no cheating x's. Okay, that's just my own silly way to remember it. It's going to want the explanation that each x has exactly 1 y, which is why I want you to get used to seeing that phrase. Okay, yes.
You have 2 quotes now. Say your M and your B, and then Albus.
I know, and you guys are going to hear it in your sleep for life, I'm telling you. All right. So it says, does it matter that there are 2 outputs of 24? Nope, because the y can do whatever it wants. Okay, so that does not matter. All right, so next we're going to go up here and it says these are super easy. Okay, and we're actually going to create a map from this, even though the directions don't tell us to, because I want to practice that. But it says use the table to identify the function. Don't overcomplicate this. You don't have to rewrite anything. You don't have to do anything. You just have to scan the table and ask yourself, do you have any cheating x's? So is this a function, yes or no? Raise your hand if you think yes. Raise your hand if you think no. Okay, if you think no, somebody tell me one reason why. What's a cheating x? Carson? 9. Hang on, that's 1. 9's a cheating x. Good. Somebody tell me the other one. Carson? Nope, I just called on Carson. Sorry. You're fine. You're fine. I'm blanking. I'm not Colton. Okay, sorry. Yes. 8. So in this case, we had 2 cheating x's, right? So, and it only takes 1, but we're going to list them both. So in this case, is it a function? And here's how I want you to write your answer, okay? And yes, this is the mathy. I want you to understand that it's no, it's not a function because 2 of the inputs, which remember those are your x's, Two of the X's have more than one output, which is the Y. But the way you're going to answer it is I want you to tell me who's cheating. Don't just say no. I want you to say no. And then I want you to list the cheater. And in this case, we have two of them to list. X equals 8 and X equals 9 have more than one. Now you can put output or Y. I don't care because they're the exact same thing. But I don't want you to just put that some random X goes to more than one Y. I want you to identify the cheater. I want you to call them out by name. Okay. Now it doesn't ask us to do this, but I want us to practice mapping. So really quickly here, we're going to construct a map. And so this is our X bubble and this is our Y bubble. And in the X bubble, right, these are our X's. We've got 8, 8, 9, 9, 10, and 12, but we're not going to put 8 and 9 in there twice. Okay. So we're only going to put each one in there once. So we're going to put 8, 9, 10, and 12. That takes care of 8, 9, 10, and 12. All right. All of those are taken care of. Now we want to put the heights in there. And again, don't write any duplicates and always start with your smallest. So we're going to put 45. That's right here. Then we're going to put 50 is next. Now 54 is next and there's two of them, but we're only going to put it in the bubble once. Then 61, then 65. Now that's just step 1 and step 2. You always have to go back, and what makes this an arrow diagram or mapping is that you need to connect who goes with who. So the 9 goes with the 54. So we're going to draw a line from the 9 to the 54. The 10 goes to the 54. So we're going to draw a line from the 10 to the 54. And I don't really care if you put arrows on the ends of each one of those lines. It clutters it up, I think. So you don't have to do it for me. The 9 goes to the 61. So the 9 also goes out to the 61. The 8 also goes out to the 45. So 8 to 45. The 12 goes out to 65. And then the 8 goes out to 50. So that 8 goes out to 50. Notice you've only got 4 X's in your bubble and 5 Y's. That right off the bat should tell you that you've got some cheating going on, right? Because you have less X's in your bubble, which means somebody's going to have to go out twice. And from the map, you can see that X is or 8 is a problem because it has 2, right? It's going out with 2 different Y's. And you can see that 9 is a problem. And just as a repeat, just to make sure, is 54 a problem? Nope, because Y's can do whatever they want. All right. So that's how you create a map from a table. You can do the same thing from a set of points. And you don't even, if the instructions don't tell you that you have to draw a map and do the mapping or do an arrow diagram, you don't have to do all of that. We can go right from the table. We answered yes or no right from the table. Scan your X's and look for any cheating. Okay. All right, so we're going to do the same thing really quickly here. And remember, I said, and this they do stick to this. They stick to what's right here. They didn't in that one unit. These are your X's on top. These are your Y's. Is this a function? Don't have to map it. Don't have to do any of that. Just, is it a function? Okay, tell me who's the cheater. Nope, those are your Y's. Y's can do whatever they want. Olivia? 54. 54 is the cheating X. Remember, you only don't want cheating X's. Y's can do whatever they want. So no, but in your explanation, name the cheater.
They have Y over X. Because 54, those are Y's.
Look at the instruction. What does it say in this try it? He reversed the order of pairs to show height versus A. Yeah, so he reversed it. And I just didn't take the time to read that, but yeah. It's kind of confusing because it's the same data. It's just he reversed it. So, but in the table, get used to, and I know that's really difficult because remember in that one lesson that we were messing with and I was fighting it because the tables weren't right and it was driving me crazy. You should always on a table see X on top. Okay. All right. So no, but for the explanation, call the cheater out by name, right? X equals 54 has more than one Y. Okay. So call the cheater out by name. And that'll help you not make an error. If you have to call it out by name, it'll help you kind of focus in on what you're answering yes or no on. All right, let's see here. I think that is everything I wanted to cover today. Looking at your homework, turn to page 169. Okay, you're gonna do numbers 7 through 13. Well, no, I'm sorry. You guys are gonna do 7 through 14. Sorry. You guys get to do the 14 because you're my advanced class. And I would like for you to try number 16. I'm not gonna grade it, but I want you to try number 16. Okay. Just give it a shot and see what you can get. It's super easy. You just scan your X's. Yeah, you don't have to do 15. How about this? If you want to do 15, I'll make it worth bonus points. Somebody was asking me earlier for bonus. If you want to do 15 and 16, I'll give you a few bonus points. Okay? So, but I want to show you something here. Okay? Don't make this harder than it has to be. For number 7, it does say make an arrow diagram from those points. So you are going to have to, right? This one's a little bit more time consuming because you are going to have to do the bubble, fill in your X's, fill in your Y's. Then for part B, is it a function? And where it says explain, you guys know what to write. If it's yes, I told you exactly what to write. If it's no, name your cheater. Okay. Number 8, don't overthink this. Read the directions. It's a very simple one. Does the relation represent a function? Yes or no? You don't have to put it in a table. You don't have to map it. Just look for cheating X's. Okay. Number 9 is the same way. It's given to you as a table. Is it a function? Yes or no? If you answer no, call out your cheater by name. Call out your X by name. Okay. Same thing for number 10. All it wants to know is it a function? See how quick some of these are? Number 11, is it a function? Yes or no? Explain. Number 12, is it a function? Yes or no? Explain. So unless it specifically says do an arrow diagram, keep it simple. Just look for a cheating X. And then down here, same thing. It wants you to do an arrow diagram for A and for B, and then for part C, which one is a function. Okay? All right. Let me know if you have any questions. If you guys are at home and you have any questions, you can shoot me an email. And if you don't have a workbook at home, you can click the link at the bottom of this assignment and it will open up a Kami version of the homework.